Hi friends, I welcome you all today's maths lecture. Today we are going to learn about factorization of polynomials. Okay, so first of all, what is factors, right? Factorization, how we can do the factors, right? How we can do the factorization. For example, if you take a number 6, if you take a number 6, so this we can write it as product of two numbers, that is 2 into 3. So now we can say that 2 and 3 are the factors of 6. Yes. So we written 6 as product of two numbers, that is 2 into 3. So therefore you can say that 2 and 3 are factors of 6. So same way we are going to apply for doing the factorization of polynomials. So whenever you have a polynomial, for example x square minus 5x plus 6, so this we are going to express it as product of two expressions. So this is what we can say that they are the factors. Okay, so in that, how we can do the factorization, you are going to learn here. So first one is, we are in the class 9th, we have to learn about factor theorem. So what is factor theorem? For example, if p of x is a polynomial, if p of x is a polynomial of degree, so for example its degree is n is greater than or equal to 1 and a is any real number, then if a is a real number, okay, if a is a real number, then you can say x minus a is a factor of p of x, if p of a is equal to 0. If p of a equal to 0 is there, then you can say that x minus a is a factor. Okay, then second one is p of a equal to, if you are getting p of a equal to 0, then you can say that x minus a is a factor. Means when you can say that x minus a is a factor, if p of a equal to 0, means in p of x you are going to put the a, so that if answer is 0, then you can say that it is a factor. So for example, we can see one example here. Okay, we can find the one factor of x square minus 5x plus 6. So what we have to do here, we have to put any value p of x, where x equal to, we can put 2. So then we can say, if we are getting p of 2 equal to 0, then you can say that if p of 2 equal to 0, then you can say that x minus 2 is a factor. Okay, so that we have to check. So first we'll find p of 2 value, right? So p of 2 is what? 2 square minus 5 into 2 plus 6. So 2 square is 4. This is minus 10 plus 6. So you are getting 4 minus 4. So the answer is 0, right? So we got p of 2 equal to 0. So you can say that, you can say now, say that is x minus 2 is a factor. X minus 2 is a factor. Yes. So when p of 2 equal to 0 is there, so you can say x minus 2 equal to, x minus 2 is a factor. Similarly, that theorem is what you see now. If p of a is 0, then you can say that x minus a is a factor. Okay, you can say x minus a is a factor. If p of a equal to 0 is there given already, then you can consider x minus a is a factor. Okay, that is what a factor theorem. Now, depend upon the factor theorem, we are going to see the sums from exercise 2.3. Okay, so question number 1, here they said determine which of the following has x plus 1 as a factor. So here we are going to check for all the questions x plus 1 is a factor or not. Okay, that is first question. So for whatever given polynomial, we take it as p of x, that is x cube plus x square plus x plus 1. So to check x plus 1 as a factor, so first what you have to do, first you have to find x plus 1 as a factor. You have to take go to 0, so x equal to, you get minus 1. So here we have to find p of minus 1. If p of minus 1 is 0, if it is 0, then you can say that it is a factor, otherwise it is not a factor. Okay, so I am going to find p of minus 1. that is minus 1 whole cube plus x square minus 1 square plus minus 1 plus 1. So minus 1 cube is minus 1, minus 1 square is plus 1, this is again minus 1, plus into minus, minus, then lastly plus 1. So you can see minus 1 plus 1 it is 0, again minus 1 plus 1 it is also 0. So answer is 0. So p of minus 1 equal to 0. So now you can say that is x equal to minus 1. This implies that minus 1 you take this side, it will be plus 1. So x plus 1 is a factor of p of x. Yes. So in this way we can find the factor, right? So in the same way we can do the next question, that is we'll take one more. So you can do the second and third as a homework. So we'll take the fourth one. Yes, we're going to take fourth question. That is fourth one is again x cube minus x square minus 2 plus root 2 x plus root 2. So this is a polynomial. Let us take it is equal to p of x. Okay. So to check x plus 1 as a factor, so what we should do, I want to check x plus 1 as a factor. So to check x plus 1 as a factor, first you have to take that x plus 1 equal to 0. So what we get x here, x equal to plus 1, you can move this side, it will be minus 1. So now we have to find p of minus 1 value. Okay. So if p of minus 1 is 0, then you can say that again x plus 1 is a factor. Okay. So here first term is x cube, that is minus 1 cube minus 1 square minus 2 plus root 2, again x is here minus 1 plus root 2, right? So now you can say minus 1 cube, it is minus 1. Okay. So power is odd number, so it will be minus only, minus 1. This is minus as it is, minus 1 square is plus 1. So here minus, then this minus into this minus. Okay. So minus into minus, it is plus 1 into this 2 plus root 2, it is 2 plus root 2 only. Okay. So last root 2 as it is. So now you can say it is minus 2 plus 2 plus root 2 plus root 2. Okay. So the answer is, this is 0, but root 2 it is 2 root 2. So it is 2 root 2 is the answer. So p of minus 1 you are getting 2 root 2. So therefore you can say that it is not equal to 0, right? So therefore you can say that x plus 1 is not a factor of p of x given polynomial. Okay. So in this way you can check whether it is a factor or not. Okay. So remaining simple questions are there. Just you can put p of minus 1 here, x equal to minus 1. So you can check whether they are the factor or not. Okay. In this way you can complete the question number 1. Next question number 2. Use factor theorem to determine whether g of x is a factor of p of x in each of the following case. Okay. So question number 2, in that first one, so we have to check, use factor theorem to determine g of x is a factor of p of x. So given p of x is a polynomial, that is 2x cube plus x square minus 2x minus 1, and g of x is given, it is x plus 1. Same question like that only. Okay. Just they represented a polynomial as one is p of x, one is g of x. So which is the factor we have to check? G of x. So if it is want to check g of x as a factor, first we have to consider that is g of x equal to 0, that is x plus 1 equal to 0. So what will get x equal to here? Plus 1, you can move that side, it is minus 1. Now you have to check the value for x equal to minus 1. Okay. So find p of minus 1 now here. Okay. So if you find p of minus 1 is 0, then you can say that it is a factor, otherwise it is not a factor. Okay. So 2 into minus 1 cube plus minus 1 square minus 2 into minus 1 minus 1. Now you can simplify this one. Minus 1 cube is minus 1 plus minus 1 square is plus 1. This one minus into minus, it is plus 2 into 1 2, last minus 1 as it is. Okay, so 2 into minus 1, it is minus 2 plus 1 plus 2 minus 1. Okay, now you can see, so it is minus 2 plus 2 plus 1 minus 1. Just I rewritten the terms. Okay, here is the terms. So now you can say what is the answer. That is minus 2 plus 2, it is 0, plus 1 minus 1, it is again 0. So you got p of minus 1 is equal to 0. So now you can say that, therefore you can say that if it is equal to 0, then you can say that x plus 1 is a factor of p of x. Factor of p of x. That is g of x is a factor of p of x. Okay, in this way you can complete the question number 1. Same way, so we are going to take question number 3. I hope you will do the question number 2. So question number 3, now we'll see the question number 3. So again we have to check g of x is a factor of p of x. Okay, so for this again we'll take quotient as a p of x, that is x cube minus 4x square plus x plus 6, and g of x is given, that is x minus 3. So which is the factor we have to check? G of x. So we have to take that is equal to 0. So now it is x minus 3 equal to 0 is there. So x equal to what we get? It is equal to 3. So now to check it is a factor, you have to find the value of x equal to 3. So now p of 3 you are going to find. Okay, so p of 3. So p of 3 is what? Now put x where x is there, you can put the 3. So 3 cube minus 4 into 3 square plus again it is 3 plus 6. Now you can say 3 cube it is 27, and here minus 4 3 square it is 9 plus this one 3 plus 6 it is 9. Okay, so 27 minus 9, 4 9s are, it is 36 plus 9. Now you can add 27 plus 9, it is again 36, this is minus 36. So answer you got 0. So p of 3 equal to you got 0, right? So now you can say yes. So if p of 3 equal to 0 is equal to 0, then you can say that, what you can say, x minus 3 is a factor. Okay, that is factor theorem. Yes, factor of p of x. Yes, that is g of x is a factor of p of x. Okay, in this way you can simplify the question number 2. I hope you can do the question number 2. Here in question number 2 you are going to take x plus 2 equal to 0, you will get x equal to minus 2. Now you find the p of minus 2. P of minus 2, if you get the answer is 0, then you can say that it is a factor, otherwise it is not a factor. Yes, okay. So now we will move to the question number 3. Yes, question number 3, that is, here we are going to find the value of k if x minus 1 is a factor of p of x in each of the following cases, right? So yes, so already you seen the factor theorem, right? What is the factor theorem? If p of a equal to 0, if it is equal to 0, then you can say that x minus a is a factor. Yes, this is first case. If you can say x minus a is a factor is given already, is a factor. If x minus a is a factor, then you can take p of a equal to 0, then you can simplify the answer. So now in the question number 3, it is given p of, that is x minus a is a factor, then you are going to find p of a equal to 0. You are going to take p of a equal to 0, then you can find the value of k. Okay, yes. So question number 3, in that we are going to do first one. So what is given? P of x is given, that is x square plus x plus k. So what is a factor here? Here they given already x minus 1 is a factor. Okay, x1 is minus 1 is a factor of p of x. If it is a factor, then what is 0? Then p of a equal to, if it is x minus 1 is a factor, then you can write p of 1 equal to 0. Yes, minus 1 you can move that side, it will be plus 1. So p of 1 equal to 0. So now p of 1, we can write p of 1 here, that is where x square plus x plus k is there, na, you can put x equal to 1. So that is 1 square plus 1 plus k, it is equal to 0. Now 1 square is 1, again plus 1 plus k equal to 0. Now you can say this is 2 plus k equal to 0. So k value is, yes, it is minus 2. So this is the value of k. Yes, in this way you can find the value of k. Okay, yes. Next we are going to see question number third one. Again here also we are going to find the value of k. Yes. So question number 3, in that third one we are going to do, again we are going to check x minus 1 is a factor or not. Okay, so again it is given polynomial is p of x, that is k x square minus root 2 x plus 1. So again they said here x minus 1 is a factor. X minus 1 is a factor of p of x. If it is a factor, then what is equal to 0? That is p of 1 equal to 0, right? So now you can put, where x is there, you can put 1. So that is k into 1 square minus root 2 x is again 1 plus 1 equal to 0. Now k into 1 square is 1 only, so this is k. This is minus root 2 into 1, that is root 2 plus 1 is equal to 0. So k value is, you can move this term to RHS side. So minus root 2 will become plus root 2 and plus 1 will become minus 1. So k equal to root 2 minus 1. So this is the value of k when x minus 1 is a factor of p of x. Okay, so in this way you can complete the remaining two sums. So simple, you can simplify and get the value of k. Okay, yes.